All right, let's finish this fucking review chapter. Jesus Christ. Jones, get your shit together. This is taking way too goddamn long. There's only 8 review sections and 7 review sections, and we've taken fucking, this is the 8th day. The fuck is going on? So, like, this is our, like, 10th day of class, day 10, but, like, really, like, our 8th day of lecture.
Is it still R6 and 7?
But yeah, we should be done today. We're working with radicals today. So I'm going to start off with something simple. Cube root of 27. I didn't notice him saying a thing until he fucking started busting his balls. So there's 2 approaches to this. One approach is for the people that like fractional exponents. I can rewrite this as 27. The base of the exponent is the 3 on the outside. There is no exponent on the inside, so it's a 1. That's one way of doing it. They're kind of connected. Some people like working with the radicals. 27 is 9 times 3. And so 9 is 3 times 3. So I got a 3, a 3, a 3. It's 3 cubed in here. So the equivalent of following this path would be having the 3 cubed in here. If you have a factor with when the exponent on a factor is greater than or equal to the index on the radical, at least one term can come out. So if the index is n, let's say that. If the index is n, and when I say index, I mean this thing right here is the index. This is called the radical sign. And the name for the interior is called the radicand. So if the index is n, for every n you pull out, put 1 on the outside. So what does that mean with my 3 to the 3? You got a cube root of 3 to the 3rd power. Which means this is 3 times 3 times 3, just as a reminder. My index equals 3. So for every 3 I pull out, I get 1 on the outside. I have to take out all three of these to do it. So this three is matched to this three, and we can pull out a three, and we're just left with a three. That would be the answer. And you can see that if you use the exponent approach. We had 3 cubed times the 1/3 is 3 to the 3 times 1/3, which is 3 to the first power. I'm gonna submit this idea by doing it, let's go a little bit further. I'm gonna use a cube root again. This next example is gonna have the cube root of 32. They're not that expensive, right?
Yeah, I lost the other one.
All right, so we want to factor the 32 and see how many there are. 32 is 8 times 4. 4 is 2 times 2. 8 is 4 times 2, which is 2 times 2 times 2. So I can rewrite 32 as 2 to the 5th power. Because I have 3 2's or 5 2's here. While this next step is optional, I'm going to show it for those that like to use it. I can break that 5 up in groups of the index outside. So I'm going to break it up in groups of 3. So 5 is 3 plus 2. So I'm going to have 1 as 2 to the 3rd power, and then 1 2 times to the 2nd power. When you do it for the one that matches the index out front, it comes outside the radical as only a single power. The 3 here cancels the 3 there. And I am left with a cube root of 2 squared, or 2 times the cube root of 4. That is the final answer. So if you like to switch it to exponents and you end up with a fractional answer, you should put it back into a radical. If you did this as an exponent, you would have had 2 to the 5th power to the 1/3, and this becomes 2 to the 5/3. Doing this as a radical, we got to turn this into a mixed fraction. This is 2 to the 1 2/3. 5/3 is 1 2/3. Which means 2 to the 1st power times 2 to the 2/3 power. And the 2/3 power gets you back to the cube root. And you've got 2 squared inside. And you can go back to that. I think that's a lot of writing. If you're comfortable just recognizing that 5 is greater than 3 and subtracting 3 from the 5 can allow me to pull one of them out. And I just do 5 minus 3. Or 5 minus the index. 2 cube root of 2 squared. Any questions? So another example is the square root of 125. When there's no number listed, the index is 2. If not listed. So let's see what 125 factors as. That's 25 times 5. And 25 is 5 times 5. So this is the square root of 5 cubed. You can either speed it up by doing 5 to the 3 minus 1 and pulling a 5 outside. And you end up with not 1 minus 2, 5 to the 3 minus 2, with the missing index 2. And you just end up with 5 root 5. That's the faster way. Or you can write it as 5 squared times 5. And then you can pull that one out without the exponent.
I did have a question about the other one, actually, on that.
Yeah,
Since we did that for the third exponent or the exponent, why wouldn't we do the same for the bottom one? It just gets rid of the outside one, so it would be 2 times 4 at that point.
what?
You know how we got rid of the exponent here, to the third, and then the cube is 2? For the top one, the 27.
I didn't about to see 27.
Yeah, you wrote the 32 one. What the hell did I get 27 from?
27 over here? Okay.
Oh, that one, yeah. For the following one, 32, why wouldn't we do the same thing for that? And get rid of the 3 on the outside?
We didn't have, because there was still stuff left on the inside. If there's still stuff left on the 27, the 3 in here maps the 3. I would, if I'd done the 3 minus 3. I just have 0 left.
Right.
So 3 to the 0 is 1. And 1 to any root is just 1. So radical is no longer needed if you get down to a 0 exponent.
Okay.
That's a good question. If you get down to a 0, for every get down to a 0. For every exponent inside. You don't need the radical anymore.
But if there is still an exponent, there is no 0, you can do radical.
Yes.
Okay.
Good question. Just like a broken clock, even Jimmy's right twice a day. That was funny.
That's neat stuff.
It was, but I don't think fucking doing it.
Those sarcastic.
Rude. Alright, I really wanna, we'll go through some of these faster, but I really wanna cement this idea in. I'm gonna go back to that. Doing the power of 2. If I have the square root of 32. And let's look at the. I want to show you the square root of 64, and I think most people know the square root of 64. It'd be something about what times itself equals 64. 8. So that should be 8. I should be able to get 8 doing the same thing I said with this factor stuff. We already showed that 32 was 2 to the 5th power. 64 is 2 to the 6th power. In both cases, it's a square root, so I'm missing. The index is 2 for both of them. So on the left one, I do 5 minus 2 Gets me a 3, I can do another -2, gets me down to 1. I'm able to take out 1, 2. I can pull out 2 2s, so a 2 squared outside. And I have 1 2 left, so a 2 to the first power on the inside. If I do that same thing over here, subtracting groups of 2, 6 minus 2 is 4, 4 minus 2 is 2, 2 minus 2 is 0. I took out 1 2, 2 2s, 3 2s. So this becomes 3 2s is 2 cubed. And along with what Jimmy was asking, this is like having a 2 to the 0 inside. But 2 to the 0 is 1. And the square root of 1 is 1. So we don't need it anymore. This is just 2 cubed. This is what I meant by being able to pull out more than 1. If you like breaking them up, 2 to the 5th power, you could write it as 2 squared times 2 squared times 2. And then now this 2 matches the index, matches the 2 outside. So I can pull out a 2 for each of them, 2 times 2. And I'm left with just this 2 right here, it goes inside. And that gets you a 4 root 2, or 2 squared. 2 cubed is 8, which is what we knew from the square root of 64. Yes,
Would any of those be acceptable as far as you would want it in the simplest form?
this is probably the best final answer form here,
Right,
and that's the best final answer form there.
I figured just that.
But it doesn't hurt to have the mid, you should probably have the mid step along the way.
But if it's something that's simple as this, you're gonna find out we just jump to it.
I wouldn't mind if you went from 32 to here to here. I think you like need to have a middle point. Another way you might like doing this, look at that 32. Square root of 32 is square root of 16 times 2. We haven't covered this property of the radicals yet, but we're doing it today. When you have two radicals or two radicals multiplied together, make one radical. Or you can break up one radical and multiplying 2 radicals. So 2 radicals multiplied together, they have to have the same index. To do this. But some of you are more comfortable immediately recognizing that 16 is 4 squared. So the square root of 16 is 4 root 2. Ready for more? So if we do something like the cube root of negative 216. $216 is 36 times 6. And 36 is 6 times 6. So I've got a good old 6 times 6 times 6, or 666, which is 6 cubed. So I could write this as negative 6 cubed like that. But this is also the same thing as negative 6 times negative 6 times negative 6. So that would be negative 6 cubed like that. When you have an odd root, an odd index allows for negative roots. This is the cube root of negative 6 cubed, which is negative 6. So we have a general rule for all this. If we have the nth root of x to the n, this has two answers. This equals the absolute value of x if n is even. And it equals just x if n is odd. This is important even for calculus. Calculus students are using this on their exam tomorrow. They're using the square root of x squared equals the absolute value of x. Something you use in calculus. The absolute value isn't necessary when it's a number. It's a number, not a variable. I haven't used absolute values on anything so far. But if I take the cube root of z to the 9th power, or z to the 6th power, let's do the square root. Just got done saying that absolute value, I need to have an even root. Do the square root. This is z squared times z squared times z squared. There's three z's that can come out. So I have z cubed. And since I don't know what sign it is, I have to put absolute value. Compared to what we did with 64. We had the square root of 2 to the 6th power. And I just said that was 2 cubed, which was 8. I didn't bother saying the absolute value sign, I just put the positive value. But for the variable, you need it. Don't need to show the absolute here.
I have a question.
Yeah,
If you pulled the three z's out, how'd you get z cubed?
z times z times z. They're not, when I wrote 3z, I meant there's 3 z's multiplied together. These are multiplied.
Mm-hmm.
So each one that comes out goes out as a z outside. Add z times z times z. And I don't have anything left.
Oh, so you're just writing it as z. cubed.
Yeah,
Okay, okay, okay.
So if you do have a remaining exponent, it does have to be in the absolute value
for an even root,
or even.
for an even root. I know, Hannah, I know you like using the fractional and things. This is the same thing as doing 7 to the 6th power over 2. And that's where another way to get the 3. But when we have a variable, we need to use absolute value sign when the root is an even root. Apply the other fun shit like square root of 3x minus 4 squared. The square root and the square power cancel each other out, but it's an even power. So I'm left with this. The way I just said it in words though might be helpful for people. Nth root cancels nth power. So this is a root with a second root or index of 2, a square root. So a 2 on the outside and a 2 on the inside, the exponent of the 2's cancel, and I'm just left with the 3x minus 4.
In the absolute.
In the absolute, well, if n is even. So if we had cube root of 2x minus 1 cubed, it's just 2x minus 1 here. Nth root, third power. So it cancels each other out. I'm just left with what's inside, 2x minus 1. That one was an odd exponent or an odd root, so I don't need the absolute values there. It sounds like a silly rule. This is why. Why the absolute? If I take the square root of 4 and I say it's 2, that's correct. But there's something else that gives an answer here. 4 equals 2 times 2, which is how we got to that point. But 4 also equals -2 times -2. So like the square root of 4 is technically plus or minus, which we usually write as plus or minus 2. This means that. We put the plus and the minus over each other, and that means the or. But when we're dealing with numbers, we usually just use the positive. But if I was using a variable, and then we don't know which one it is, so they just say, we're gonna force it to be the positive one. The absolute value sign forces the positive.
It's gonna be
Yeah,
So it's only absolute value if the exponent on the inside is odd. What if like the.
No, if the root, the index on the outside is all that matters.
Oh, the minute, not the inside,
The inside doesn't matter.
so. So if it was, if the index was 2. It would be absolute value.
Yeah. If we have a square root, we have a 4th root. We have a 6th root, we have an 8th root, we're gonna have an absolute value.
It doesn't matter the inside, the x going to be inside.
Other than to pull it out, it has to match.
Yeah,
That's all that matters. Alright. Do some more,
Give me a minute, sir.
okay?
Got it. Think.
You good?
Yes, I'm fair. Thank you.
So some rules. I said this before, showing with the 16 times 2 is 32. But if we have the nth root of A and we multiply it by the nth root of B. This equals the nth root of A times B. We have a fun one that says the nth root of A over the nth root of B. Guess what this does? It turns to division on the inside. And the one that you see so fucking rarely that I could probably count the number of times I've had it on my fucking, not like a problem where I actually needed it, this information on my hand. I can count it on one hand. And like fucking doing math at this level for like 15, 20 years. If we have the mth root of the nth root of x, this is the m plus n root of x. Not plus, times. So like this is the cube root of the square root of x equals the 6th root of x. That's an example of that one. We're gonna do examples of the other two right now. Let's do the square root of 5 times square root of 45. This is the square root of 5 times 45, which is the square root of 225. I think like if you're using a calculator, this is that like if you're using a calculator, you're just gonna put this shit in. But like at some point, the calculator fucking slows you down. It really does. I can write this as the square root of 5 times the square root of 9 times 5. Avoiding the calculator here. And that becomes square root of 5 times square root of 5 times square root of 9. This is square root of 5 squared. And square root of 9 is already simple as 3. But here the root and the exponent cancel out, and we're left with 5 times 3 is 15. The square root of 225 is 15. So get it right there. We have like the fifth root of n times the fifth root of n to the fourth power. I could put these together as this is n to the fourth power plus 1. No exponent means there's a 1. So I have the fifth root of n to the fifth power, which is just n. Where you might use it in division, if I have the square root of 49 over 64. This is the square root of 49 over the square root of 64. And hopefully you know the square root of 49 is 7, the square root of 64 is 8. Because 49 and 64 are perfect squares. Strong variant.
I was like trying to figure out the difference between the two on the bottom, those you read. It's like really not the same, but then I still like.
The radical split on top and bottom here.
I like some of those things.
Darian might be glasses. You know you can get some cool like fucking sports
No,
looking glasses.
I don't know.
Why you gotta say it like it's a bad thing? The fuck? Or we could have something like this, square root of 33 over square root of 81. I meant to start this as 1, and I fucked up because I was winging it. Split it up going that way, and then the square root of 81 is 9. 33 isn't a perfect square, so we just kind of gotta leave it alone. And it doesn't factor to where anything factors out either. Right?
Contagious,
I even fucking had a nice little nap today.
nice.
I planned my entire fucking semester around nap time. I have on Sunday, Tuesdays, and Thursdays, I have morning classes. I have like from 8 to 12, I have classes on Tuesdays and Thursdays. But rather than having like another class and like in the afternoon, I have a class from 4 to 7 also. So I go home, have lunch with my wife, I go and take a nice little nap. Fucking nap time is great. Pandemic led to nap time. I was never a nap person. And the fucking pandemic came along and like I can't give up my naps no more. I like them.
The latest you're here to 7 for the week. Or latest you have class, at least.
What?
Latest you have class at.
Yeah. Alright, so we got some rules for radicals. Radicals are simplified when. After we write the list, we'll take a little break real quick. Before we start working with them. One, the radicand has no factor with an exponent. With an exponent greater than the index.
Okay. That's fine.
Has no factor. Thank you. If there's fractions involved. There are no radicals in the denominator. Or on the bottom, since that's quicker and shorter to write than denominator. The exponent inside and the index. Have no common factors. I think that one's confusing enough. I wanna like show a quick example here real quick. If I had the sixth root of x cubed. This is x to the 3/6 power. Which is x to the 1/2. 6 and 3 have a 3 in common. But I can rewrite this as the square root of x. And now there's a 2 on the index and a 1 on the exponent, they don't have anything in common. So if you have something where like you can divide and simplify it some, you should. And finally, all operations have been performed. Let's take a 5-minute break. And then we will knock this shit out. Get it done. What did you think I was talking about?
I thought you said, I thought we were talking about that.
Alright. So let's go with square root of 175. This is 175 is like $1.75, which is 7 quarters, or 7 times 25. Which is 7 times 5 squared. You can choose to break this up into square root of 7 times square root of 5 squared. Or you can jump straight to the answer here, which is 5 square root of 7. What if we had like the -8 times. Cube root of 27. Been 10 minutes, bro. It's been 10 minutes, bro. Fucking look at the clock. You're getting bold these days. This is cube root of 3q. We just did that earlier. And like the 3 exponent on the inside matches the index, it can come out. We have -8 times 3. This is why step 4 is listed, all operations have been performed. You don't stop at -8 times 3, you leave it as -24. I had fun telling people that Louise told me to fuck off last week. And like, it was the 5th week of class, and I already got a student telling me to fuck off.
That's it.
And like, it was great, and they're like, did you throw them out? I'm like, no, fucking clapped. They look at me funny, like, I try to develop a relationship with the students where they can just chat with me. I'm not a fucking, this unapproachable teacher. Unapproachable teachers suck. Fuck all that. Alright,
Very true.
cube root of, ooh, there's a lot going on here. 128, A to the 6th power, B to the 8th power, C to the 10th power. Ah, more power. I will help you out and let you know that 128 is 2 to the 7th power. So. You have some choices. A good way of doing it is breaking it up into the individual things. So I have 2 to the 7th power. How many times can I subtract 3 before I can't anymore? I can do -3, which gets me a 4, and I can do minus another 3, which gets me to a 1. Which means this is 2 cubed times 2 cubed times 2 to the 1st power. Which means I got a 3 index, I can pull 2 2s out. And it leaves behind 1 2 inside. I can write the a to the 6th power as a cubed times a cubed. Or you can just do, which shows us that I should be able to pull out 2 a's times a squared. So like, if I put the roots over it, this is like putting the cube root over a to the 6 equals the cube root over a cubed times the cube root over a cubed. So I get a times a. If I do the same thing with b to the 8th power, I can have a b cubed times a b cubed times a b squared. So I can pull out 2 of them. I'll have a b squared here. And I still have 2 left over, so I gotta have a cube root of b squared here. So the a didn't need another radical because there's nothing left over, but the b needed another radical because we didn't take out perfect number. For C, we have C to the 10th power, and we're effectively dividing that by 3. We get 3 1/3. So we should be able to pull out 3 C's. And we still have a cube root of C left. So C to the 3rd times C to the 3rd times C to the 3rd times C. All right, there's a lot of shit going on here. So. If we were looking at this right here. Let's put everything that doesn't have a radical in the front. I've got 2 squared. I've got A squared. I've got B squared. I've got C cubed. And then I have a bunch of cube roots left. I have a 2, I have a B squared, and I have a C. C squared though is 4, so we can go 4A squared, B squared, C cubed. And inside is 2B squared C. And that would be the final answer. Or most simplified. What's up, Darian?
Get the part where you put the star down. It's that,
Where I did what?
where you put the little blue star, then you get.
I was just saying what I was pulling down here.
No, yeah, I know that, but how did you, like, do that whole section?
Okay. So first off, I broke it up into these up here.
Yeah.
Okay, focusing on the 128. 128 is 2 to the 7th power. So. Let me cover off everything but the part I'm looking at. 2 to the 7th power, I can write as 2 cubed, 2 cubed, and 2.
Okay, that's what that is.
So that I end up with a 2 squared out front. And I still have 1 left, so I gotta have a 2 on the inside, and I still have a 2. So it'll be cube root of 2. Does that make sense?
Yeah.
I did that for each one of these. So cube root of A to the 6 gave me A squared. By doing A times A to the 3rd power times A to the 3rd power.
Yeah.
Are you good?
Yeah.
Okay. Alright, so the homework will give you plenty of opportunity to practice on that some more. Something important to know, if radicans are what we call like. We can add and subtract them.
And side of that.
Yes. So like, I think showing the next example, it like. Helps right away. If I have 15. Cube root of. X squared y minus. 7 cube root of x squared y. These have the same index, same radicand. So I can treat this as 15 minus 7 times the cube root of x squared y, or 8 cube root of x squared y. We're effectively factoring out the radicand. Factoring out the radical sign, radical. That's what we're doing. If it helps you. Change the blues or red so it stands out. I can say u equals cube root of x squared y. And then this looks like 15u minus 7u. I get a u. And then you plug it back in, you replace u. Fuck you laughing about, Luis? The fuck's he laughing about, Darian? Snitch on him.
I was opening your bag or something. He doesn't wanna like make a distraction. So it's
Oh.
like,
Alright, so. Next example, we're gonna have the square root of 75ab cubed. Minus b. 12ab. In the radical, like that.
That's 75 or 7 times 5.
75.
Sorry, so I'm dying.
Yeah, that was the pin, sorry. So this is 3 times 5 squared. AB cubed. Minus b times 12 is 4 times 3. Or 2 squared times 3ab. I try to write them in their factors so that I see what comes out. Here, a 5 and a b will come out. And I should be left with 3ab.
I have a question.
Yeah,
How did you bring the 3 out? I mean the 5 or the b out if it has a 3.
I treated the b cubed as b squared times b. And the b squared comes out as a b.
Okay.
Any other questions? On this one, all I can take out is a 2. And I'm left with the 3ab. Now my radicands look like. So I can combine them. I have 5b minus 2b, which is 3b. Ready for more?
Good.
I'm gonna give you guys a couple minutes or a minute or so on the next one. Let's give you the fifth root. X to the 12th power, Y to the 15th power. Try to simplify that. You ready for football?
It's a short one. But it's watchable on there. Excited for football, like we do for games.
I don't get excited for games unless I'm gonna be playing it.
What's that?
I don't get excited to watch someone else play it.
Are you in sports?
I would be excited to play for the NFL. I don't know, watching someone else play sport is not as fun as doing it yourself.
Do you watch games?
No, I don't watch other people game.
Really?
I know there are people that love watching Twitch. To watch people game online, and to me, no. The only time I've watched someone game was a YouTube video where some guy introduced his girlfriend to the Dark Souls game series. And he wanted to show that someone that even doesn't play video games ever, with some practice and some patience, can get through Dark Souls. She was cussing up all sorts of things, just constantly getting slaughtered. The game is really hard. She eventually got better and made it through the game. I didn't watch the whole thing, and it was like I watched like 15 minutes of it, and then he like had little cuts to where he jumped ahead. But no. All right, so one way of doing this, if you got, let's get to the answer right now. If you had x squared y cubed times the fifth root of x squared, you have the right answer. So one way of doing this is breaking those up into powers of 5. And for each one we have that has the power of 5, the 5 matches the index, I can pull out an x. I've got an x, I've got an x, so we multiply them. That one is stuck, can't go anywhere because it doesn't have a 5 as an exponent. This one comes out as a y. This comes out as a y, and this comes out as a y, and these are all multiplied together. So x squared y cubed, and we still have the unlucky x squared that's stuck inside. I want to point out something that you guys may not notice that I do consistently. I make this ledge stick out pretty flat. And I have a tail that comes down off the end. The reason why is if I have two like, what does that mean? This is a 2. Is this 2 cubed times the square root of xyz? Is it 2 times the cube root of something? So like I have 2 cubed here is 8. Over here, the 3 is on the index. If you put out a nice little flat ledge, you can make it clear it is not an exponent for what comes before. Having the tail come down, if I brought the tail down here, I can see quickly that I meant only xy on the inside. And the z is on the outside. That it's not the cube root of xyz, which is different. It's a different answer, it's a different value. So, and if you just had it where it was like, well, was I lazy and I didn't just, was it laziness? Should this have come out further? I don't know. But if you drop a tail down at the end of your radical, you always know where it ends. So even if you're coming, you're like fucking someone knocks on the door, Jehovah's Witnesses are outside, fucking want to, you know, spare your immortal soul, and they trap you at the door for an hour and a half. When you come back, you'll know exactly what you were doing. All of a sudden, fire alarm goes off, or fucking sister left the bathtub running and it's flooded. You're like, oh fuck, I gotta go clean up the water before like the boards fucking get wet on the floor. It's helpful. Let's take a look at the 6th root of the cube root of 4 squared. I think this is ultimately easier by turning this into exponents. This is harder than hell to remember that this is 6 times 3 with the 4 squared. Oops, 4 squared, which would be 18 with the 4 squared. This is much easier to write as 4 squared. The cube root is 1/3. The 6th root is 1/6. This is 4 times 2 or not times, raised to the 2/18 power. 2/18 simplifies, it's 1/9. So this is the 9th root of 4. So by converting it to exponents, it's also easier to catch the fact that the index and the exponent here were both even. So we don't want to leave them where they have a common factor of 2. So you write them as the exponents is the easier way to go.
Be the 9 root of 4 is the answer.
Yeah, 9 3 to 4 is the answer there. All right, let's talk about multiplying radicals. Or just look at doing them. We already showed you that they can go inside each other, like. That times that, like A times B is AB. But what I meant by doing multiplying radicals is like if we had more going on. Like, let's say the square root of 11 plus the square root of 17. Times the square root of 11 minus the square root of 17. Now, an astute mind will see that this speeds up quicker. But if I multiply these two, I get square root of 11 squared. And then I have a plus square root of 11 times square root of 17 minus the square root of 11 times square root of 17. And then I've got a minus square root of 17 times square root of 17 is square root of 17 squared. Here, the square root and the square cancel each other out, that's just 11. I have root 11 times root 17 with a plus. And then I have the same thing with the minus. Those two just cancel each other out. And finally, I have minus the square root of 17 squared. The square root and the square cancel each other out and hit minus 17. This is just -6. You may have, if you look for the patterns, you can speed up your work. This was a plus b times a minus b, which is a squared minus b squared.
Find the 2 square root of 11 which is the same for the 17 is because it makes a negative.
The negative's on the outside.
Right, so
Okay,
you wouldn't do the same thing for the 17. Square root of 17.
I don't understand. I had the square root of 11 squared.
Yeah.
I got 11.
You wouldn't do the same thing for the square root of 17 square root of 17 squared.
I did, I got 17. But the minus is between them. Yeah, I did do it.
My bad, I didn't see that.
It's all good. These two are called conjugates of each other. We'll have all sorts of conjugates. But it's where you have this same setup. A plus B, the conjugate of A plus B is A minus B. And vice versa, the conjugate of A minus B is A plus B. We use this to solve shit, as you'll see in a little bit. For radicals, if we do it a specific way, we can see it gets rid of radicals, right? I start off with 2 radicals being multiplied together, I didn't end with them. They don't always cancel out very well, sometimes you gotta do more work. If I have 5 plus the square root of 32 times 3 minus the square root of 2, You should simplify the square root of 32 first. That's square root of 16 times square root of 2, which is 4 root 2. So this becomes 5 plus 4 root 2 times 3 minus square root of 2. So 5 times 3 gives us 15. Then we have 5 times negative square root of 2 is negative 5 square root of 2. The 5 does not go inside because it's not a radical itself, it's just a whole number. Then I do the 4 times the square root of 2 here times the 3. The 4 times the 3 are what get multiplied together. And we leave the root 2 alone. And then we've got 4 root 2 times negative square root of 2. This is negative 4 times square root of 2 squared. Or you could put negative 4 times 2 times 2 like that. This part is just a 2. So for the numbers that don't have radicals left, I've got a 15 and I've got minus 4 times 2. 15 minus 4 times 2 is 15 minus 8, which is 7. And these have the same radical with the radicand, so I can combine them. Negative 5 plus 12 is plus 7 square root 2. Is ready for more? So you just multiplying stuff out like we do with the when we had parentheses before. Another thing we have to worry about is rationalizing denominators. So if I have like 3 over the square root of 5. We don't want to have a radical in the denominator. No radicals on bottom. So we're going to take advantage of square root of x times square root of x is square root of x squared, which is x. We're going to take advantage of this. To do that, I need to multiply the bottom by the square root of 5. But if I multiply the bottom and not the top, I'm actually changing the value. So I'm going to multiply the top and the bottom by the square root of 5. This is effectively multiplying by 1. And if I multiply by 1, it doesn't change the value. So I have a 3√5 on top. On bottom, I have square root of 5 times square root of 5. The squares cancel out, and I'm just left with 5. That's the answer. What if I had 7 over the square root of 7?
That's not part of the same.
Multiply the top and bottom by square root of 7.
Just
So this becomes 7 square root of 7 on top. And the bottom is 7. So this actually simplifies a little bit more.
just part of the same.
It's just square root of 7. The 7's cancel. We'll take this a step further. Now I got a plus sign on the bottom. We showed a little bit ago that if we multiplied by a conjugate, the radicals went away. So that's what we want to do, multiply by the conjugate. And that's just a word you're gonna have to remember. Do you not have another word for it? We're gonna use it when we do complex stuff as well. The conjugate of 3 plus the square root of 7 is 3 minus the square root of 7. If I do it on bottom, I need to do it on top. This bottom is like a plus b times a minus b. That's the difference of squares formula. So the top is 2 times 3 minus square root of 7. The bottom is the 3 squared minus the square root of 7 squared. I recommend when you get to this point, deal with the bottom first before multiplying through on the top, because you might get lucky and it might cancel out. Three squared is 9 and square root of 7 squared is 7. And this bottom is a 2. I have 2 times 3 minus square root of 7 over 2. And since I hadn't multiplied it through already on top, I can see the 2's cancel out easier. This is just 3 minus the square root of 7. Fucking did it a second ago, so don't tell me we're both doing it.
We started.
I'll finish it too. That's right. Good ethic. Flexing his yawn muscle. When I was your age, the It was like it's called the Lions Restaurant, it's a restaurant that had a bar in it.
The weather.
It was called the Lions Restaurant, it was in Sacramento. For Monday Night Football, they would, come in, buy a drink. And you get your card punched, and like every like third game was like something free. It was never free alcohol, but there's like free different apps, so the final one was like a free dinner. From the restaurant, we go in there, I get a nice little vodka cran and I've been watching football. I do miss that time.
They're not there anymore.
No, I don't know. Sometimes I miss, watching football in general.
Yeah, no, that's what I'm saying, is that bar
I
restaurant.
have no idea, it's in Sacramento, I don't think it's there anymore though. Alright, let's do another one real quick. Sometimes it's even got a radical on top. You need to focus on multiplying by the correct conjugate though. We want to get rid of the bottom. We do not want a radical on bottom. No radicals on the bottom. So if I just multiplied by square root of 3, my 5 would have a square root of 3 also. That doesn't work. We have to use the conjugate. And if I do the bottom times it, I gotta do the top times it. And so I'm gonna throw in some parentheses so you see them. This is a minus b times a plus b, which is a squared minus b squared, which in our case is 5 squared minus root 3 squared. So this is my bottom that I'm doing right now. 5 squared is 25, square root of 3 squared is 3. So I'm gonna have a 22 on bottom. I have 4 plus square root of 3 times 5 plus square root of 3 over 22. I don't see anything happening there, so I'm gonna multiply some shit out. Multiplying the top, I get 4 times 5 is 20. Plus 4 times the square root of 3 is 4 square root of 3. Then I move to the next one, plus square root of 3 times 5 is plus 5 square root of 3. And then I've got plus square root of 3 squared. This is, that's just 3 right there, right? The square root of 3 squared is just 3. So I've got, this has no radical, that has no radical. 20 plus 3 is 23. These both have a root 3, so I can add them together. 4 plus 5 is 9. So 9 root 3. And the bottom is still 22. Nine or 22 doesn't simplify with any of that shit on top, so that's the answer. Now, whether the computer, like if you're entering a computer, it may take it that way, you may have to write this. The equivalent version of this is 23 over 22 plus 9 over 22 square root of 3. That's the same thing. Or you can have the radical on top over here, but you can have the radical on the side. We've got one more god awful topic in this entire thing, and we're almost done with chapter R. And then I think shit gets easier. I really did. I think you're gonna go 1.1 is a fucking joke. We'll see. Fucking look at me when I am. Alright, so If we have radical expressions with fractions. If I have the cube root of a to the fifth power times b over the cube root of a squared b to the fifth power. This is radical expression with fractions. This is easier to work with if you make it one big radical. Then simplify what you can before dealing with the radical. A to the fifth power over a squared is a to the 5 minus 2, gives me a cubed. B to the first power over b to the fifth power is b to the 1 minus 5, is b to the negative 4. So I'm going to leave this as a cubed on top, and then I'm going to put the b to the fourth power down here. Now split it back up. Cube root of a cubed over cube root of b to the fourth power. The top is a, the bottom is b times the cube root of b. And we don't want to leave it like that. This cube root of b is b to the 1/3. We do not want a radical on bottom. I need to multiply this cube root of b times something so that I end up with b to the first power. Earlier, when we had square root of 7 on bottom, we were able to multiply by square root of 7. But if I multiply by cube root of b here, I don't have enough. Remember, the exponents have to add here. So this is like a b to the 1/3 plus what equals b to the 1.
Plus 3.
2/3. So I need to multiply this by b to the 2/3 over b to the 2/3, which is cube root of b squared. Did you have a question, Josue?
No, I was saying, trying to say, you asked, and I was trying to answer, but I was wrong.
Okay. Nothing wrong with that. It's a good way to learn.
Oh, like to 2/3 was the answer, but I was saying that 3.
Oh.
Yeah.
So we want the fraction, we want to do a fraction so that we add to this so that it gives us a 1. So the top part here is going to be a times b to the 2/3, which is cube root of b squared. I'm going to put it back in its radical form. These two parts right here just make b. And I already had a b up front. So I got b times b is b squared. That would be the final form of that son of a bitch. It's not friendly looking, is it? Doesn't have to be. You'll be doing stuff like this throughout all the problems. And let's call it a wrap. You can GTFO if you're ready. You didn't even fucking barely finish fucking writing. Jimmy's fucking like teleporting out of his goddamn chair.